So without further ado, I would like to kick off with Andrew Jones. So Andrew.
Hey.
Nice to have you here. Thanks for coming.
It's fun to be back here, and even if not in physical form.
Yes, and I guess we could just start. We could start with a question. Do you want to just start by telling us what you've been working on for the last year? Anything new?
Some new speakers.
Okay. Okay.
one of which is I keep saying this is about to launch this month or next month, and it's imminent because we've already done some mass production, just a small production run just to check that everything's working out okay, and it's arriving to me next week, and so I can check that they did all the last things that I said they needed to get fixed, and so it should be available in the next couple of months for shipping, and it's sort of going to be no surprise as to what it is if you look at the past history of what we've been doing with each of our speakers. It's a better version of Unify 2.0, put it that way.
Okay, and what's the price point?
It's going to, I guess, the bookshelf $800 to $900, $8 to $9, not $8,900. So still very affordable, and it's sounding, well, of course it's sounding really good. When I was listening to it, it's kind of, the vocal reproduction is what got to me first. I was just listening to all these different vocal tracks and thinking, yeah, that's just what I want the voice to sound like. And it's an interesting reaction because, first of all, I have that reaction. Oh, that's just what I was hoping to get. But the other is, it's just what I want the vocal to sound like. And that's an important point. Because I know I probably said a lot of this when I was up there last time. But these things keep cropping up as to what constitutes the sound of a speaker. What's the target for the sound? How do you know you got it right? How much do measurements play into that? And there's a growing number of people that review that are getting test equipment and setting it up and making measurements. The problem is, it's not just can you make an accurate measurement, and with the simple test gear, no, you can't. I've been going through with some of the DIY guys that are friends with, and I've been going through a process of building a calibration speaker so everybody could test their microphones. And that'll be ready soon. And I'm just going to ship it on this round robin, round lots of different DIY members, and say, make a measurement, send me the file. And we'll compare just what variation in responses that these guys get. I did it once with the IEC committee. Back when I was at KEF, Laurie Fincham was on the IEC committee. And all the IEC, whatever the number of it is, I always forget it, for testing speakers. A lot of those new standards came about because of those discussions when Laurie was on that panel. And one of which is when you're specifying a method of measurement to establish what is a frequency response, how do you determine that? Because in the old days, a lot of measurement, or a lot of the standards were based on take the B&K 4133 microphone with this amplifier and this chart recorder and sweep at this rate, and that defines what the measurement of that is. And standards shouldn't be that. Standards shouldn't be referring specifically to pieces of equipment. They should be referring to equipment that meets a certain standard to be able to measure, and then used in a certain way to determine what the measurement of the device under test is. So what I did was I built a calibration speaker. I measured it, and then we passed it around Europe through various members of the IEC, those people who were on the committee trying to set a standard of how to measure a speaker. We thought it'd be just fun to see, okay, so you're all working on this standard. What is your capability of getting a consistent measurement? And the variation was surprising. To me anyway, and yet some of the members said, oh, it's within about a dB or two. How do you determine that that's acceptable for a standard method of measurement? So I thought it would, when I look at these cheap microphones that you can buy now, the ECM 800 and the all these other ones, they come with calibration curves. But I've measured a few of those, and I don't necessarily believe those calibration curves. So I started my own process of establishing what I was doing, because while I was working on a project with KEF at the Technical University of Copenhagen, they got one of Europe's largest anechoic chambers. It was huge. They were big in acoustics. They work with Brüel and Kjær on a consistent basis for electroacoustic research. And one of the guys there, his research project was how do you absolutely calibrate a microphone, and not just a reference against some known standard. Just like when we say, what is a meter? Well, you reference it against a physical meter that's held in a special room in Paris until very recently, until they redefined it in terms of wavelength of light. But there was a physical standard. So everything you had as a standard was referenced to something else rather than an absolute. And this guy there are ways with microphone calibration using 3 reversible transducers to do absolute calibration. And then it's how accurate can we do that? And he was working to hundredths of a dB in his standardization, which is very, very difficult. Now, I'm not saying that was over the whole frequency range, but to specify, say, a sensitivity or a sound pressure level to that degree of accuracy, it was interesting. So to see people accepting these microphones with so-called calibrations, and they're not really that close, it bugs me. And so I've got such a range of microphones in my lab that I've collected through the years, that of different sizes, that I can do cross calibrations between them and hopefully feel satisfied that at least out to 20K, I've got a measurement microphone that is thoroughly understood. And then having got that, because it'd be embarrassing if my microphone was out and I sent out this calibration microphone and someone else said, no, I think I'm doing mine more accurately than you. And I was wrong.
Andrew, when you're constructing a new speaker, I had a question that came up when you were talking about your new product. Is technology or the price point what drives you to develop a new speaker? Because I assume every speaker you produce to be as good as you can get it at a certain price point. So what is it that then makes you say the next year, oh, I want to do something new? Is it that the technology has trickled down and now you can get better components for a lower price? Or is it that new components come out, or you just come up with a new design?
Sometimes I like to say sometimes I come up with new ideas, and I've got some in my head that I want to be trying to exploit. Some ideas that I know can work just need to be turned into product. Others are in a way more fanciful, in that this would be cool if it does what I'm hoping it will do. The question is, my acoustic understanding of this concept, is it the correct one? And so I need to do some research work to establish that, either by computer modeling, but that's mathematics, so I have to find someone to do that for me. Programs like COMSOL or those kind of things, they are very, very complex electroacoustic modeling. And that sort of process is beyond me. I never claimed to be that good at math. That's why you have teams, like when I was working on the TAD speaker behind me, literally, this one, that drive unit. So I was working with the Japanese on that. And since Japan had got the technology for making the beryllium cones, my first thought was, when we were brainstorming what could my first reference speaker be for TAD, because I'd already determined that we needed to do a higher end speaker within the Pioneer umbrella, but what would it be called? What brand would it be? Because a $70,000 Pioneer speaker is not going to fly, but TAD will. So we started developing this, and so we make the cones, the mid-range cone, by vapor deposition onto a copper former, and then we etch away the copper to leave just the pure beryllium. And so we need a shape. And since I was going to do a concentric driver, I knew the shapes I had been using in all my previous concentric drivers. And they'd been developed partly as the shape I need for a waveguide, and partly as the shape I need to act as a good mid-range driver. So I took one of those kind of shapes, and I had them build the tool so that it could be made, and we put it into the chamber, and we made some cones, and we built it up into a speaker, and it was awful. I mean, the breakup mode was very high, somewhere around 10K, but there was a strong dip at about 2K of about 6 dB. I'm thinking, how? First of all, I've never seen that in a cone before, and I knew it wasn't the surround, because often with cones, you'll get a dip around 800-900 hertz, which is the surround going into an anti-resonance with the cone. But this wasn't at that frequency. It's nothing to do with the surround. What was causing it? And so I had them, we'd done finite element analysis to understand what this cone was going to be doing, but we hadn't done any boundary element analysis. So we knew how it's moving, but we hadn't calculated how that movement translates to the sound radiation from the surface of the cone and the baffle around it. So I had one of the guys over there, he'd written his own BEM program for his laptop, and it took 2.5 days to run to solve it. And so we ran a boundary element, and sure enough, it showed that there was a dip in the response at 2K. And it's basically because of the depth of the cone and phase loss between center, plus also not having, if we put a solid dust cap over it, the problem went away. But because it was a cone and kind of nothing in that middle, caused the problem. So we postulated that, well, if we reduce the depth of the cone, we should be able to move that dip higher in frequency and smaller in level. So then it can be just part of the overall shape that gets adjusted in the roll-off slope of the crossover. So we built a new one, and it worked. So you come up with ideas of what ought to work, but you have to modify it once you try and build something. So my next job is, I've got these ideas, and if they work as I think they will, it'll be really, really good idea. So keep your fingers crossed that I got that part right. So some of it is technology driven. Every so often I'll have a flash of inspiration and think, oh, which product can I incorporate it into? And it depends on what it would cost to implement that technology idea. Is it going to be reserved for a higher end speaker because it's expensive and it's cutting edge of materials, for example? Or is it a a neat idea that can actually be built at low cost, and so you can incorporate it into an affordable speaker. So there's that side of things. The other is that I've never built a perfect speaker. Nobody has. And in recent years, I've obviously been concentrating on the very affordable speakers. So they're never right. They're as right as you can make them within the cost constraints. And every time you do one, you learn something about how you want to play around with where you apportion your money. And sometimes you choose one direction, and then later on you think, yeah, I know I gave up on the cabinet a bit to be able to afford everything else, but I wish I hadn't had to, because I'm attuned to the sound of cabinets, and maybe I need to fix that next time round. So then it might be, instead of just having more abstract thoughts of ideas that you want to implement, they're thoughts driven by limitations that you've been exposed to. And then you start thinking, okay, how do I get around that limitation and afford to get around that limitation? And so every time
Stephen Sharp has a series of questions that I think feeds into what you're talking about. So I'm going to, there's three of them. They all kind of go together. How do you control for varied customer room environments? Do the footer designs come into play? How the speaker will sit, rug, hardwood floor, as well as walls, ceilings, and how frame design? Does time alignment and sitting position come into play in design testing? What about cable and amp variables as to speaker design?
Yeah, that's a huge subject, isn't it? It's always easy to ask a question. It's much more difficult to answer all of that.
How do you deal with that varied environments?
So what I've always said, one of my mantras, is the problem with speakers is that they are a three-dimensional device, not a one-dimensional device. You know, an amplifier has got an input and an output, and it's not influenced by its environment in that sense. A speaker is totally influenced by its environment. I've always said, if you don't know how to set up a speaker in a room, you're not really a speaker designer, because the room is an integral part of what the speaker is going to do. Just recently, someone was talking about designing for cars, and they said, oh, that's very much more difficult because the car is a very different, awkward acoustic environment. And I'm going, sort of, in one way, not really, because it's absolutely fixed. If you're designing for a new model of car, say you're working with Ford on the release of the next best car, once you've worked with the interior design and you've got your speaker locations and you've decided what you're going to do and you've tuned it up and you've got the sound that you want in that car, it's never going to change. So you know that the sound that you developed for that car is a sound that everybody can hear. Whereas you design a speaker for a living room and the acoustic environments are so different. And also in a car, all the associated head units and everything is all fixed. So you kind of know what you're going to get. So how do you deal with that? I do like to go online and see posts of how people are using my speakers. You know, there's two Facebook forums, ELAC owners and ELAC owners international, something like that. And so I'm on those threads and I look at all the pictures that people have proudly posted. Oh, look, I just got my ELAC speakers. And I try not to be judgmental on what I see of how people set up systems, because that's not what you should be doing with a speaker in a particular room. Is not what everybody can do or understand that they need to do. So there's an education process in how do you set up the speaker correctly. But every room is so different. The furnishings, whether it's a live acoustic or a more dead acoustic, where the openings, where are the windows, where are openings into other rooms, and what freedom do you have both in placement of the speakers and your listening location. It's very, very difficult to know that it's going to sound great in all those locations. The best I can do is, through the years of developing speakers, just have ideas of sound balance, directivity that are likely to be benign for most acoustic environments. And also, I have to set them up in hotel rooms, well, not this year, I didn't, or last year. But the experience, whenever any company I've been involved with has done a show, I've always gone out and I've set up that room. And you learn a lot by doing that. You don't want to let someone else, even if it's in a different country, I don't rely on a distributor setting it up and me walking in at the last minute and think that I'm necessarily going to get good sound. And it's not just whether I have any degree of trust in some distributors, some I don't, but some I do, some absolutely know what they're doing. But unless you yourself have gone into that room and started listening to that room and adjusting everything until you get good sound, then you'll never know what contributed to getting that sound, whether the room was really bad to begin with or whether somebody got lucky. That process has been invaluable to having an idea of how my speakers are going to sound in different environments. And of course, one of the things is directivity control. Every speaker I've done has got some kind of waveguide on it to try and match the tweeter directivity to the mid-range, or it's a concentric driver that does an even better job of controlling directivity. So there are steps I take to try and help. But it's limited with a passive speaker because it's, you don't generally put level controls, passive level controls on the woofer and the mid-range and the tweeter. Well, certainly not on the woofer. But we used to, but just like with tone controls, if you do that, everybody says, you can't do that. That's not pure. And of course, it costs money to do that. So you kind of get a balance that, I've said from the point of view of measurements, none of the speakers measure perfectly on all axes, and certain aspects that, especially with affordable speakers, you just have to follow. Simple cabinet construction. You don't have big rounded baffles on the front because those cost a lot of money. All these kind of things. So the cabinet tends to be very formulaic in baffle shape and location of drivers on that baffle, which causes acoustic problems. So you do your best with waveguides to try and ameliorate it, but you'll also find that having a flat on axis response is not necessarily the best thing to do. And yet a lot of people with simple measurement techniques, when they review them or test for themselves, they will look at a non-flat on axis response and go, this isn't very flat. And some of the DIYers will go, well, I got a flatter response than that speaker has. Going, yeah, but did you look at the off axis and which directions? And do you know which directions the off axis perturbations are more critical than others? So every time you're doing something, you're balancing those trade-offs and then listening. And I've said many times that I'm pretty much always end up bringing prototypes to certain shows, just because you're trying to develop something new. It's not quite as ready as you planned it to be for the show, especially CES was always that way. And so I bring along my prototype and I let people listen to it. But it's also an opportunity for me to listen to it in that particular room, with getting comments from lots of people to help me determine, am I going in the right direction? And of course, there's always the thing that if someone says that sounds really good, I go, yeah, that's not bad for a prototype, is it? And if someone says, no, it's got some problems, I go, yeah, I know, it's only a prototype. You can kind of get out of jail free card by doing that. It's when it's already in production and someone says, "Oh, I don't like the sound of that." You kind of, "Oh, okay, I can't please everybody."
Well, Andrew, I've heard lots of your prototypes in your rooms, and they typically sound pretty great. So I don't know how much do you usually change from what you bring around to what's finally shipped? Are you?
It's generally the drivers are pretty much developed at that point. So it would be more to do with what I'm doing with the crossover, balancing the different off-axis responses, maybe some fine-tuning of cabinet vibration and how the driver's interacting with that, maybe a bit of bass tuning, some small adjustment to that. But, I mean, not huge, although sometimes it's surprising how just relatively small changes in frequency response in particular areas can have quite a big impact on your impression of the speaker, either the tonality of it or the spaciousness of the sound field. So it's worth spending quite a bit of time at the end of the process, having measured it and having understood what it's doing. Then it's down to me listening and saying which factors are affecting my sound impression for what I want to hear with the recordings I choose to listen to.
So at the end of the day, it's your ears that are the final determinant.
Yes, and it's been mine. And it's not like I canvass lots of people's opinions from within ELAC or Pioneer or whatever and try and do a compromise. I mean, nobody at ELAC has tried to suggest I change anything. I had a worry when I was first developing this TAD, because I'm working with all the Japanese engineers, and they're brilliant speaker engineers. But we've all had this thought that in the past, people would say, well, the Japanese don't know how to design speakers. And it's absolutely not true. They're some of the best engineers I've ever met. What they were choosing to have as the sound that they were going for might have been different from what we were choosing. I mean, the British sound for speakers, or USA, West Coast versus East Coast, same kind of things. There were fads on what people wanted the sound system to sound like. And Japan had different ideas. And when we were working on this, because I proposed the project in the first place, I was given the honor of being in charge. And, if there were any disagreements, I was told that, well, Andrew, Sam, you have the final say-so. That's a huge responsibility, hoping we wouldn't have any disagreement, so I wouldn't have to sort of pull rank. But we never did. And I think partly it was because we were working at such a high quality level that everything that they were looking for, that they wanted to hear from the recordings they were evaluating with, also worked for the recordings I was listening to and wanting to hear from those recordings. But it was remarkable. We never had disagreements. So, but all the time, it's really been just me making that decision. And it's fortunate that enough people like the sound that I like. It's not universal. I mean, you can clearly see by discussions on forums that some people will argue against what I've done. They'll prefer something else, and that's fine. You can't pretend to all like the same thing. Otherwise, we'd have no variety in life, no variety in people. You just have to be... it's like any reviews that you get. If the review is good, you tend to think, oh, I know what I'm doing. What happens if the review is bad? You can't accept a good review, but reject the bad review in one sense, because they're all opinions, and you can't just say the only opinion that matters is the one that agrees with me. So you have to just say they are their opinions, and hopefully I get more that like what I do than dislike what I do, and then I can stay in business.
Okay, Andrew, we've got a pile of questions piling up
Yeah.
here. Let me get to
Because I talk too much. I told you the answers are the more difficult part.
No, we've got. I'm trying to mix the questions with what you're doing. So, I had the same question. What musical sources are you listening to, and do you have an album list? And I think when I've seen you play at shows, you have quite a variety of things that you play. So, kind of, what's your go-to?
Quickest way to answer that, if any of you are on Qobuz, I've got something that's called either Andrew Jones demo list or ELAC Andrew Jones demo list.
Oh, I didn't see that.
And it's a whole lot of things. I started to put it together because I was going to be doing I did do a talk on Qobuz. But before that, I'd actually been chatting with, I'd got an email from Rick Rubin, and I've demoed my speakers to him lots of times. I've been to his house and his studio and everything, and he'd sent me an email saying, "Hey Andrew, I'm getting back into listening to a variety of speakers, and I know you got great taste in music. Can you put together a playlist for me?" Oh, yes, if you put it like that. So I thought the easiest way, since I know we got access to Qobuz, I just put it on Qobuz. And so it's like I said, it's a good variety of things. And so look for that, and then you'll be able to try them out.
Here, we have some other questions here. Does by-wiring versus by-amping improve the sound from a good loudspeaker? If so, why?
So I could make a technical argument, even for by-wiring, why it might make a small difference. And I'm not saying audible. I'm saying let's start with measurement first, because when you apply a voltage to a drive unit, the current flow will be non-linear because the BL curve is not perfectly linear. So the current flow, if you put a linear voltage to a linear resistance, the current flow will be linear. If you put the linear voltage to a non-linear resistance, obviously the current flow will be non-linear. Well, because the drive unit, the impedance is a combination of the impedance seen going in the forward direction and coming back once the coil's moving, then it's a non-linear current flow. So imagine we've got the tweeter and the woofer through the crossover come to a ground point, which is the negative terminal of the speaker. Then you got wire going to the amplifier. So the true ground is back at the amplifier. It's not at the speaker. That cable has got a certain amount of resistance. So what's now happening is nonlinear current flow through the tweeter is generating a nonlinear voltage across that wire. So the reference point that the voltage applied across the woofer has got nonlinear voltage applied to it by a very small amount, and vice versa. So you've got some nonlinear contamination between the two drivers. Whereas if you separate those wires and ground them only directly at the amplifier, and the amplifier then is a true ground point, you remove that contamination. Can you hear that? That's up to you. I'm just saying I can think of a reason why there could technically be a difference, but it'd be very small. And of course, the simplest way is put a thicker piece of wire so there's less resistance in the way. But so that's one aspect. If we look at, there's no other reason, you don't get more power, you don't get more voltage swing by doing that. So that, to me, is the reason why there could potentially be a difference. When it comes to biamping, what we mean is passive biamping, not active biamping. So passive biamping is you use two identical amplifiers, or at least identical gain amplifiers, one for the tweeter, one for the woofer. What does that give you? Well, if they were both of the same power output compared to just a single amplifier, you have no more voltage swing available. None. It's not like you filtered. It's not like an active system. The same signal, voltage-wise, is being applied to both amplifiers and appearing across the speakers. Exactly the same voltage. The current flow on a music signal will be different because since you're going through a passive crossover to get to the woofer or through a passive crossover to get to the tweeter, in the pass band, obviously, there should be very little attenuation through the crossover. In the stop band, obviously, there's attenuation. And what you see is, if you look at the impedance looking in, then in the stop band, the impedance will rise at 6 dB per octave. So the current flow into modulation distortion in the amplifier. So modest potential improvements when you buy amp, but not necessarily huge. If you're going to double the cost of your amplifier, you'd be much better off just buying a single 200 watt amplifier than buying two 100 watt amplifiers.
Okay. Another question: would you ever consider designing a planar or a horn speaker?
This is a horn speaker, if you think about it. I mean, it gets into the old adage, what is a horn speaker, right? Yeah. What we think of as horn speakers are compression driver horn combinations. So we get the extreme advantage of, or the best advantage of a horn by operating a larger diaphragm through a phase plug into a small throat, which then enters the horn. So we want that to get a wavefront that is the same phase across the whole wavefront as it's going into the horn. The horn then expands that wavefront from planar to semicircular, and through all those actions improves the efficiency potentially greatly. Now, waveguide is just that without using a compression driver. And some horns, if you look at when you think of Klipsch, for example, established from the very beginning with the corner horn and all those kind of things, they were compression loaded horn drivers. But the low cost $200 or $300 or $500 speakers still have horn tweeters, but not compression drivers. It's a regular tweeter, but going into a horn, or what I would call a waveguide. A more generic term would be a waveguide. It's guiding the wave coming out of the throat. And it's either an extreme example, which we tend to call horns, or it's just a means of controlling directivity. Because every horn, the only reason it is efficient is it's matching to the air better. It's taking a small throat and expanding it to a large mouth. Its directivity, in one sense, you can say the only reason it seems efficient is it's restricted the direction in which the sound is radiating. That's the way it achieves those high sound pressure levels. So the reason a horn has a cutoff frequency below which it doesn't really couple well is limited size. So to get wider bandwidth from a horn, you have to have bigger and bigger and bigger horns. To get efficiency at low frequencies, you have to have a huge horn. So you'll often see horns where the low frequency response is still basically either a closed box or vented box. It's not particularly efficient at that very low frequency. You need huge horns for that, large mouths. That's why the corner loaded worked. It's put into a corner so that the corners of the room and the floor act as an extension to the horn. So then sort of you are inside the horn. And that's the way you couple and get the additional benefit of efficiency improvement at the very lowest frequencies.
Cool. Here's another one. This is the amazing one. I own your new Unified 2. They sound amazing. How do you achieve the wide off-axis soundstage with a bookshelf speaker design?
It's not so much whether it's a bookshelf or not. If you think about there's two things going on. One is whenever you put a drive unit on a baffle, the baffle will have diffraction effects. And it's sort of believed that there's an optimum width of baffle that is the best one for getting the best directivity effects. And there's ongoing debate about that. It's always been said, well, because bookshelves have narrow baffles, then you'll get better sound staging from that. It's not entirely true, but certainly it might have been in the days when bookshelves were smaller both in height, depth, and width. And then as you went to the tower speakers, suppose you design a range of speakers over a range of price points and performances. You got the small bookshelf with let's say a 5-inch driver, then the next step up with a 6-inch, then you might have an 8-inch version, then you go to a tower with still that 8-inch driver but in a bigger box, and then you add more bass drivers, and then maybe you have a 10-inch bass driver in there as well. These days, when we talk about tower speakers, everybody wants narrow, so the way you get more output is you just keep on adding drivers, either multiple 5-inch drivers or multiple 6.5. There's not so many that have got 8-inch drivers these days because people want these slim speakers. Or if they're going to put big drivers on them, they put them at the sides. And then that creates problems in how do you load it into the room, because do you have to make a mirror image pair? Do you have outies or innies? Do the drivers face each other or do they face the walls? How does it load the room compared to a forward-facing driver? Will it? And you'll get questions like, well, surely a bass drum is facing you and it moves and it pushes the air in front of it. How can it sound the same if a driver is pushing it to the side? So there are people who will believe that side-firing woofers work, some people who are against it. But so we tend to have similar speakers these days in terms of baffle width and what effect it will have on dispersion, and hence primarily imaging. And when you put just a drive unit on the surface of a baffle, you've maximized the disruption of the sound re-radiated from the edge. And in order to stop that sharp discontinuity in radiation pattern when the sound reaches the edge, you want to round it. But a small amount of round over is worthless. You need like a 2-inch radius round over to fully ameliorate that. So most cabinets are not built like that. For cost reasons, you build square edges. And so these ones that have an additional baffle with just a small amount of rounding at the edge, it doesn't really do anything. The other way is to have a wide baffle, but curve it backwards, right? Like this one. The second way to try and minimize the effect and improve the directivity response, improve the responsive axis, improve imaging, is a concentric driver. Well, let's start waveguide. By moving the driver backwards behind the baffle and then putting in a waveguide that expands the sound out before it reaches the baffle. Just like when I said with a horn, you're expanding a wavefront from a small start at the throat to a bigger wavefront at the edge of the horn. Putting in a waveguide is doing a similar kind of thing. And when you think about baffle diffraction, the worst diffraction is with a small sound source on a larger baffle area that gets terminated. Woofers have diffraction, but the shape of that diffraction response is much more benign because the ratio of the area of the woofer to the area of the baffle, it's much closer. So tweeter is worst case. So if you can set the tweeter behind the baffle and let its wavefront expand through the action of the waveguide to be larger before it starts to spread across the baffle, you can start to reduce some of the ripples you see in the response due to the cabinet edges. And so waveguides do that. And since a concentric driver is basically a tweeter in a radiating waveguide, the radiating waveguide being the mid-range cone, then that also helps as well. So anything that improves both the on-axis smoothness and maintains the same basic frequency response, whether you're on-axis or off-axis, is a good thing in terms of both sound quality, but also imaging and image depth and soundstage.
Andrew, I've got a question related to that. What are your thoughts about the time domain, coherence in the time domain, with different frequencies leaving the speaker at different times and arriving at your ears at the right time?
So that's interesting. Do they arrive at your ears at the same time, right? Let's say I accept that you want the sound from the tweeter arrive at the ear at the same time as the woofer, right? So we start as a basis for that. How do we achieve that? Since a typical woofer and a tweeter, the voice coils are not, if you just mount them straight onto the baffle of the speaker, then clearly the tweeter is closer to you. If we think of the voice coil as being the originator of the sound, then the voice coil of the tweeter is clearly closer to you than the woofer is. So how do you align those? Well, sloping baffle is one way. And so now you slope the baffle such that the differential delay at the point of where you're listening, at the listening height you're at, they both arrive at the same time. Sounds easy. Or you do the stepped baffle, like in the old BMW Kangaroo speaker. Maybe that's just for us British people. the DM6, it looked like we called it the pregnant kangaroo. But well, I know Kef did, since they were our main rivals. So you got step baffle, you got sloping baffle, or waveguide. If you put it in a waveguide, you can move those voice coils to be in the same plane. The problem with all of those is that those wavefronts, and that's assuming that the source of the wavefront is the voice coil. Now, you could pretty much say it is with a tweeter. It actually isn't with a woofer, because you got transit time from voice coil through the material. And whereas, since the material of the cone, the speed of propagation of waves in the cone is much faster than the air, then the center of the voice coil, the center of the cone gets the wave first and starts radiating. The outer surfaces get it later, but they're closer. So you've got all these differences in balance of what exactly is the timing of that wavefront. But let's still just assume it's the voice coil, and we've lined up the voice coils. They only arrive in time at one position in space, one location, both height-wise and distance from the speaker and on axis. Take a stepped baffle or a sloping baffle and listen to it from the side. They're clearly no longer time aligned. Stand up, slump down. They're no longer time aligned. There's literally only one point in out of 360-degree space where they're time aligned. Are we really so sensitive to the direct sound of the speaker that overwhelms every other impression of that wavefront that we're hearing, because it's not aligned anywhere else? So the only way you can align it everywhere is to have truly coincident concentric speakers doing it sort of this way. Now, I won't go into the arguments of whether people believe that, well, there are other disadvantages of doing a concentric speaker or whatever. But I'm just saying, from a physical point of view, that's the only time you will align the wavefronts pretty much everywhere in space. So then we come to say, oh, all right, so we've said you can't, practically in most implementations of how we do speakers, align them perfectly other than one location in space. How much does it matter in the first place? Are we killing ourselves to do this? Are we, in order to try and do that, are we compromising other aspects of design? Because so far, I've only talked about, well, physical alignment, assuming you know when the source of the sound propagates. But you have a crossover in there, and crossovers are not time coherent. Almost, say 99.9% of crossovers on the market are not time coherent. I'm not talking about the crossover network itself. I'm talking about the electroacoustic transform from input electrical signal to output acoustic. That can only be phase coherent in a multi-system, let's say a two-way system, if the electroacoustic transfer function is first order for the crossover. And even if you put in a first order electrical network on, the electroacoustic transfer function will not be first order, because drive units are not infinite bandwidth. If they were, why did we need a crossover and two different drive units to start with? So that affects the time coherency, regardless of what we do with positioning voice coils. We then start to look, well, how could we make a substantially electroacoustic transfer function of first order? Teal attempted to do that. You have to have very wide bandwidth drivers, very gentle crossover slopes, and you have to compensate for the roll off the drivers so that the electroacoustic stays first order enough. Is 20 dB down and then let it go wrong good enough? Those are judgments. And that's to get it still only aligned at one point in space. And in order to have such a low roll-off rate from the drivers themselves have to have extraordinary control of their cone resonances, out way beyond what you'd have from a higher order crossover. And the tweeter has to have extraordinary movement capability and power handling capability, because you're going to be putting in significant energy at levels way above what a higher order electrical network would give you. So for that one advantage, you've potentially got to engineer a whole host of problems to get around. And then on top of that, you say, okay, so is what I'm hearing when I've designed this speaker, was it actually due to the time coherency? Because one of the problems with doing any scientific experiment is controlling your variables in that experiment. Every experiment needs to be single variable. If it's multivariable, you've got a whole host of data processing you've got to do to try and isolate from a multivariable result the variable that you are actually trying to ascertain. And most people designing speakers are certainly not doing that. They're certainly doing the other thing, uncontrolled experiments. There are ways of taking time coherent transducers. Certainly headphones, you get a better chance of having a time coherent transducer. Let's say a net static headphone, hopefully a smaller diameter one than a big one. And then taking signals and deliberately in the electrical domain, altering the time coherency of that, and then listening to the result and saying, can I hear a difference? Not which do I prefer, because what did we do in the recording process? Maybe you start with a recording process that's just a pair of microphones, or mono, do it in mono microphone, B&K standard microphone. Make a recording of a signal and then say which sounds closest, but certainly what sounds different. Can I hear the effect of screwing up phase response. Because you can take a perfect electrical signal and put it through a first order and a second order and a third order electrical network, add them back up together electrically and apply it to that transducer, and then say, can I hear when I bypass the sum of the LF crossover plus high frequency crossover? Now, in my mind, my primary function is never to go for time coherency. For me, it compromises so many other aspects of what I'm trying to design for, that if I'm looking and it turns out to be reasonably okay, hey, I'll take it. I stand more of a chance with a concentric driver than I do spaced conventional drivers. But it's not my driving function for when I'm designing.
Andrew, what do you think about open baffle speakers?
Cheaper than a box. You know, I know Siegfried was a great proponent of that. And he and I, we've had many conversations about speaker designers through the years, because he was, you know, a long-time friend of Kev and Laurie Fincham. So he would, whenever he was visiting, he would always come and we'd have talks with him at Kev and give him free drivers and all this kind of stuff. And he moved away from box speakers, going to more dipole radiators. And I mean, the first thing, when you're trying to build just an open baffle speaker, which technology are you going to use? Is it going to be a magneplanar type, an electrostatic type, or is it moving coils of drivers put on baffles? At least when you're doing a planar type speaker, you don't have any baffle surface as a radiator. It's all drive unit, basically. So the way it interacts with the baffle is going to be very different from putting smaller diameter drivers onto a larger plane baffle. You back into diffraction issues by doing that. Not worse than a regular speaker, but you've now introduced those. Then you've got vibration issues. You have vibration issues in cabinets, and you brace them or whatever. It's a bit more difficult to control the vibration of just a flat panel rather than something that's part of a construction. So you need to deal with that. I went to a DIY event where this guy, there's quite a few people in the DIY community bring along open baffle type speakers. This guy had taken it to the extreme where there's literally no baffles and it's just the drive unit. And the drive units were all hung on string from this frame and free to move, which is a great thing. Trying to stop a drive unit from moving is much more difficult than just, what the hell, let it move. Because if it moves, it's a very simple motion that it has, and a very linear with frequency motion. It takes away a fraction of the sensitivity, nothing to speak of, but it doesn't introduce any vibrational modes from panels and cabinets and whatever. So this guy basically has hung his drivers on strings, except for the very lowest frequency driver. And it sounded actually quite good. The downside of doing open baffles is for the loss, a box stops the rear radiation from the drive unit, obviously getting round to the front, because otherwise it would cancel at a rate of 6 dB per octave, increasing cancellation as you go down in frequency. So you have to make up for that loss of radiation by increasing the excursion of the drive unit a lot as you go down in frequency and equalizing it. So particularly with a bass driver, the design work that you do for a bass driver for an open baffle speaker is very different. It has to be a very long throw, but you don't need much force factor because you're not overcoming stiffness of the air in the cabinet. And you typically have a higher Q driver because you use some of its lift through resonance to compensate for some of the falling that you get due to the phase cancellation between front and back. So the design of the drivers for optimizing for open baffle is very different from what you do for closed back. Then you got different room interaction. And we know this obviously from electrostatic speakers and magnetoplanar type speakers, that you can't put a dipole close to the wall. I want to do a little poll, and people can put this in the Q&A or the chat. If I talk about the back, if I've got a speaker and I talk about the back wall, am I talking about the back wall or the front wall? What do you define it as? It's the speaker to, it's the wall to the back of the speaker, but it's the front wall as far as you as a listener is concerned. What do people use? Because I've been in a discussion recently about what it is. And especially when people ask, how far from the back wall do you place your speaker? Do you mean how far from the front wall? Because someone facetiously said, Kev said 40 centimeters. Well, my room is longer than 40 centimeters, so I can't do that because they wanted the speaker 40 centimeters from the back wall, which means it's here, right? With my head against the wall, the speaker is here. So just a little thing you can answer in the comments. So you can't put a dipole speaker close to that wall that's behind the speaker because since the sound radiating from the rear is exactly inverse to the sound from the front, you don't just get the general wraparound, you get a full reflection of that sound at all frequencies, and you get no bass. So you've got very different room requirements for placement. And you also don't get low frequency pressurization of the room. Theoretically, with a closed box speaker, if you seal all your doors and windows, you can produce DC sound pressure in a room. You can't do that with an open baffle. It has no DC response. Nor does a vented box, but a closed box theoretically does. And there are some subwoofers that sort of rely on that, going down to 3 hertz in a room or below, simply due to that pressurization. So you got that factor going on. And there's sort of a theoretical, certainly with microphones, when we think about ratio of direct sound to reverberant sound energy, you know, a cardioid has more direct sound and reverberant sound, cardioid microphone, than an omni, and a hypercardioid has a different ratio, and a figure of 8 has a different ratio, and the speaker, you know, dipole speaker is a figure of 8. So you've got 3 dB less reverberant energy in a large space from a dipole compared to have with a monopole. Unfortunately, our listening rooms are small room acoustics, and that doesn't quite apply. And the idea that you're minimizing standing waves because there's no radiation in the plane of the baffle is not really accurate either fully. Small room acoustics are different. So, you know, there's some simplistic ideas that we think we want to apply to design, and then when we get further into it, we realize, it's not that simple either. So I've certainly heard some very interesting dipoles. I, of course, have listened for years with electrostatic speakers. I've got a big collection of electrostatic speakers, and I enjoy them, but they are very different. And overall, I'd say I've tended to favor doing box speakers than open baffle. But I understand that, you know, the attraction of open baffle. And if, like me, you're not a very good woodworker, it's certainly easier to build an open baffle speaker than it is a closed baffle speaker.
Okay. Hey, Andrew, I think it's show and tell time. So we've got more questions.
Where's my dog?
Why don't you show us what you're sitting in front of? Show us your system, and you can talk about your speaker a bit and do the little show and tell, and then we can get back to some questions, and we'll.
Okay. So obviously this is the, well, obvious to me anyway, this is the TAD Model 1. So very first high-end speaker I ever did, really. I think it launched at $45,000 a pair, which was way underpriced because we were selling it directly out of the factory of Pioneer USA. By the time it became the reference one, it was nearly double the price. So that's the first one. So it's the Berlin mid-range Berlin tweeter. This whole mid-range, well, this whole head for the mid-range enclosure is floating on mounts underneath there to separate it out from the main cabinet. And then in addition, this whole mid-range unit is pushed in on O-ring seals, so it can't transmit vibration into this. And this is a cast head made of an aluminum powder epoxy resin. And then this baffle is made the same way. It's a cast resin and aluminum baffle, 8-inch mid bass driver, 10-inch and two 10-inch bass drivers vented out the bottom. And the base cabinet is 52 layers of 3/4 inch plywood laminated up, and each layer is machined to give you the outer shape and the inner cutout. So any bracing is integral to the sidewalls. It's not glued in. It is part of that construction. And once you stack them all up, then it's all glued together, and 14 coats of an epoxy resin coating, which hopefully holds it together, which didn't always happen. Sometimes we had the reason we eventually gave up doing this is every so often we get a customer going, I thought someone had shot me. I was in the listening room and suddenly there was this bang. And what would happen? The plywood would let go, but because we'd got it coated in this epoxy, the noise of that crack propagating through the epoxy would be this loud bang. So eventually we said, yeah, we need to give up on that. Alon Wolf, with his first speakers, his first bookshelves, he was laminating wood, but not using an epoxy resin coating, so he didn't have quite the same issues. So that's that. And then, and here, just so cute. That's the other woofer. So this is Mochi, who's a Maltese and Yorkie. So he's a Morkie. So that's one of them. So let's slide this back, and then I'll move the chair out of the way. This way, I think. Without knocking anything over. So I think there you can start to see some other bits and pieces. Let's see if I want to try moving my laptop and see what we get. So what have we got there? So Lin turntable at the top, and then we have a Barder DAC, Berkeley Audio Design, from your neck of the woods. Beneath it, not very well lit, but Audio Alchemy, or ELAC Alchemy, the DAC pre and the 2-channel power amp. Below that, I have my Stax SR1M, I think it is. It's the tube headphone amplifier for the electrostatic speakers. I've got one of our ELAC amplifiers here. Down at the bottom, I've got my VTL 200-watt 2-channel tube amplifier, so I can switch between solid state or tube. And there's the SR007 headphones. And then over there in the room, I've also got my, you can't see them very well. They're not placed properly yet, but I've got the powered ELAC Navis floor standing speakers. So that's what I've got in this room. Not perfectly well set up. That's because living in a condo, it's not necessarily very easy to play loud, but that's the advantage that I have, in that I design these for a living. So I have a very good listening room at work, and so I do evaluate speakers. I bring them home to try out here. In fact, when we were developing this speaker, when you're developing things in a lab environment, you don't get a really good sense of size, of how much will that speaker disrupt a living room. So I got the foam core board, and I built a mock-up of this speaker and brought it home to see how big it looked in a real furnished environment, and it looked huge. Didn't stop me bringing home the final one though, because that was it's sort of the speaker I'm most proud of, because it was both the first real high-end speaker I'd done, but also so many new ideas. The method of construction and the isolation of that mid-range unit, and it's being beryllium, and developed these underhung, every driver was developed specifically for this, and multinational team working on it. Alan Boothroyd did the industrial design on it. And in fact, when he was working on it, I made sure that he was working under guidance from a view of what he'd be allowed to do, since this was going to be a reference standard product. Whenever you're doing industrial design on a speaker, going back to the amplifier being a one-dimensional device, that what you do to the looks of it doesn't influence the performance. The speaker is a three-dimensional device. Everything you do to it influences the performance. And industrial design strongly influences the performance. So we developed this concentric driver, and I knew that the optimum shape to put it in was a sort of semi-spherical shape. And I actually found a fluorescent light fitting bowl that looked like a flattened sphere. And I was able to mount the drive unit in that and say, this is the perfect shape from a diffraction point of view. I can measure it in the anechoic chamber. But I know I'm going to have mid-bass drivers and bass drivers. What do I do? How will one screw up the sound of the other? And so I said to Alan, this is the best thing for a concentric driver. This is the size of structure I'm going to need for the woofers. Let's start to say, how could you incorporate those two very different shapes together? And every time he'd draw a sketch, I'd build up a mock-up in wood and go into the anechoic chamber and start with the concentric and the woofers. I'd measure each of them separately for range of microphone positions. Then I'd start just moving them together till they interfered more and more with each other, to see what is the limits of how can they approach each other, what height difference affects it, what width imbalance affects it. And that allowed me to hone in on this shape. So that was a fun project. And so these have remained in my house ever since. We launched these in 2003. So it's been a long time.
Have you thought about making another kind of cost no object pair of speakers?
Always thinking. Those thoughts are getting closer and closer to reality. So yes, at some point I will definitely be doing it. Yeah.
Can you talk about how you might change it today? I mean, it's almost 20 years later.
Actually, it's sort of related to that question, is that pretty much all the drivers that TAD is still using in the reference one, they haven't changed in 20 years. It's the exact same drivers. They are so good that there hasn't really been a better material made available than beryllium. There's diamond, of course. So there's diamond tweeters, and some people are using a mixture of a beryllium diaphragm with a light crust of diamond on it. But in terms of mid-range units, there's only one other manufacturer that I'm aware of, which is Paradigm, that's done I think it's a 5-inch beryllium mid-range driver. But it's not vapor deposited, it's one of the foils. So it's got slightly different characteristics. But there aren't really any materials that are outperforming beryllium yet. there might be some coming along, but not fully outperforming. So it's done remarkably well. And why change a winning formula? You can still optimize how you use those drivers. So I'm not sure yet, as I begin to think about high-end speakers, what diaphragm material I would be focusing on. Would I go to Berlin and try and do a next generation kind of Berlin driver? Maybe, but I haven't determined that. There's other things I'm thinking through that I want to achieve that are a limiting factor. But I can't give ideas away. Not this soon.
All right. Let's just talk about just general industry things. What's the next show you're going to show up at? Are you?
Oh, yeah. So I was surprised to see that the show had announced
Tentatively.
Long Beach in June, mid-June.
Yeah, aggressive.
The way Los Angeles is going, I don't see that.
They
I
said
don't see
they
that.
time.
I mean, even if I've got my vaccine by then, it gets back to the reality of the vaccine isn't necessarily making you not catch COVID. It's ameliorating the effects of it when you get it. So we haven't determined that it doesn't mean that you're not still spreading it yourself to some degree. We've done remarkably, I'm not getting politics, but we've done remarkably well at getting to this point from a vaccine point of view. We haven't got it distributed well enough yet. We haven't got enough people taking it. And a lot of the questions that you would answer over a 3-year period haven't been answered yet, not out in a general population. So I don't know it's worth taking that kind of risk that early. Is August, September, October a better time? I think we wait and see. We've got a lot of shows still at this point planned to go ahead. We've got Axpona, we've got Munich. God knows how people are going to do both Axpona and Munich with the closeness of them and try and ship product back and forth. With affordable product, it's not so bad. But if you've got a $50,000 amplifier and you only really have one that you ship from each of the shows, that's not easy to do. It's been notoriously difficult to get product back in time from Munich back to the US for other shows. And there's what's happening in September.
The Pacific Audio Show is at the end of July, beginning of August. Not planning on that either.
I know that's unfortunate for them, that it's just still a bit too early. October for Rocky Mountain, maybe. I just don't know yet. We're all playing a wait and see game.
So
because
for anything yet?
No, there's obviously we're committed to Axpona because we've got our money, as everybody knows. So it doesn't mean we will do it. We're on the books to do it. Will it go ahead? In what format will it go ahead? I don't know. So I'd love to do Munich. I love doing Munich, but is it too early? I'd say the most realistic timing would be for Rocky Mountain. But I just don't know.
And how have your sales been over the last year? What's been selling?
I think we're in a product category that's been selling very well, which is affordable. Either affordable for newcomers or affordable as your second system. Audiophiles who've got a system who now, they're at home all the time and they want music everywhere and we want something better for the office. So our sales have been very healthy last year. We were very worried what the situation would be. And I know it's affected lots of people, and not every hi-fi company has had an easy time, but you know, fingers crossed, we've done well. So I won't say we've prospered and grown, but we've held our own, let's say. And we were surprised. You know, we were applying for loans just like everyone else in expectation of it being really bad, but we've kind of done okay.
And you have home theater speakers too, right?
Yes.
Yeah. And how's that? And we had a question about Atmos, Atmos audio and having Atmos speakers, which you don't have.
We do.
Oh, you do.
We do. We developed one for the debut series where it crosses over between being either useful with the debut speaker or with the Unify from a price point of view. We sell a lot of those because it's a concentric driver, which is perfect for when you're doing a Atmos topper, the upward firing one. And in fact, when Dolby first presented the concept of Atmos to us, when I was at Pioneer, I didn't get to hear it straight away. They wouldn't let me in. They let Chris in, but they were too nervous that I might figure out too much of what they were doing or something, but they wouldn't let me in. When I finally heard it, I was blown away by it. More than any other of the surround sound schemes, Atmos for me was the one that got me excited. But I looked at what they were doing with the initial presentation they gave to me, and they're going, it's bad enough trying to get people to put in 5 speakers or 7 speakers, but now you want all these extra speakers, that and in ceiling and in the walls and floor standers or whatever. And I was saying, you guys are crazy. And then they said, but sort of one more thing kind of idea. And they showed us the upward firing modules. And for me, in the environment that they showed us, I preferred the sound of those. And the great idea behind it is if you can run speaker wires already to a front pair of speakers and in additional to your rear speakers, then you can just double that up, and it's very simple to do. They're going to the same locations as you've already got speakers. And so once they started to explain how the upward firing modules worked and what the requirements were for directivity, I was thinking, perfect for a concentric driver. So that's what we developed. So I did it first with Pioneer, but because it was all new, the first Atmos speaker we did for Pioneer it was a concentric driver. It was like a Unified was developed out of what I was doing at Pioneer, but it was a concentric driver built into the top of the cabinet for the Atmos and a concentric driver facing forward. So it was all in one. And it was very, very nice sounding speaker. And my mantra was, well, even if you're not interested in Atmos, just treat it as a spare driver in case you blow the main concentric. You just swap them over and you've still got a working speaker. But I've been interested in it ever since. I like the idea of multi-channel audio mix for Atmos. It can sound really interesting if you kind of going away from the purity of stereo to multi-channel audio. I like what it does, and what Dolby have done with their up mixer of taking a standard stereo signal and doing pseudo surround with it. It sounds like a heretical thing to say, but they've actually got that done so well that it can be very enjoyable taking a regular stereo feed and up mixing it into Atmos. So, both at Pioneer, but also ELAC, we did Atmos toppers, and they sell very well because of the price point. Most Atmos toppers are much higher in price.
And so it sounds like you've had a lot of home theater speaker buyers with everybody home.
I mean, when you go to higher end, if you're selling higher end audio, tends to be more stereo based than home theater. I have actually designed with TAD. We did design a center channel speaker, but I mean, it was just huge and hugely expensive. And we built some prototypes, and they have found their ways into some people's homes around the world. But the market for that at that price level was too low for us to make it a viable full product.
We had a question, any plans for a headphone design?
I get asked this a lot. I certainly have a fascination. My brother, my identical twin brother, has had 30 years experience in headphones because he does noise cancelling headphones. There's lots of patents on concepts of how to improve noise cancelling headsets. So he's great at small scale acoustics, or small scale electroacoustics, shall we say, and I'm more on the bigger scale. And the idea of combining our knowledge and doing something has always fascinated me. It's not that I want to be a headphone speaker company, but it'd be fun to try something. And I've had ideas. It's just, I mean, look at how many speakers I've developed and put out through ELAC. There's lots of them, and it's just time. You know, where do we concentrate our energies? And I know we can say that speakers are a saturated market, and yet we still made inroads into it for, you know, a relatively new brand, at least in the US market. But headphones is also super saturated. And how do you make space for yourself there? One of the guys who's in charge of one of the headphone websites, he'd said, yeah, but anything with your name on it would create its space. And that's, I don't mean that sound big-headed, but from the point of view of, if I've got a reputation of doing really good, affordable speakers, I could take the viewpoint that, yeah, like we've said, that I design speakers to sound how I want them to, with the kinds of music I'm using to evaluate. You know, it's kind of a vicious circle, that. But if I were to do a headphone, even if it didn't have gobsmacking new technology or something, if it was one that sounded to me like I wanted my headphone to sound like, that represented the sound I like to hear from those recordings, then would that be sufficient to be able to sell something without it being new technology? And I muse about that. Just like with car systems, I have been involved with designing in-car sound to try and get business for Pioneer and TAD with the big car companies. I did a development project for Lincoln, for Cadillac, and then for Lexus. And what we did for Lexus actually got incorporated. I think the LC 500 has got its top of the range non-branded sound system is actually a TAD system with TAD concentric drivers and stuff. And I was involved in the early stages of that project. I was able to design a sound in that car, or the prototype car, that sounded how I want a sound system to sound. It's kind of taking my home system and getting that sound in a car, but turning up the bass a bit more because it's fun to have lots of bass in a car. And so the idea of, well, when I listen on headphones, I don't hear the sound that I'm used to hearing from my speakers at home. So is that the idea? Design headphones that satisfy me to be my personal taste in headphones. Actually, the stacks come very close from a sound balance point of view of what I like to hear from headphones. But, you know, those are the thoughts that amuse me when I'm trying to get to sleep or not being able to get to sleep, but I've never acted on them. They fascinate me, and the concepts of what I could do fascinate me, but it's never gone beyond just thinking about it.
Okay, we have a couple of questions. Oh, David, did you have something?
Well, I was just going to say, you mentioned that you've designed a lot of speakers. I couldn't even hazard a guess at how many you've designed through ELAC. Do you have an idea? Could you put a number on it?
I mean, in 6 years, and it's not everyone made it to market or into the home audio market, because there's been in walls and in ceilings and stuff. But in that period, there's got to be about 40 of more, something like that.
Busy.
Just in a small market space. Yeah, in that
Yeah.
time period, it's a lot. Yeah.
We have a couple of questions about kind of tweaks. Do you have a general approach to speaker placement and toe-in sitting position for your designs?
Yes, never point them at your head. That's my general mantra. The general rule is you got this equilateral triangle, and you toe them in so that they face directly at your head. I never, ever do that with a speaker. It's the point of maximum symmetry, the maximum disturbance of cabinet diffraction, especially with a concentric driver. For all the benefits that a concentric driver has, the worst aspect that you try and design out is that dead on axis, you'll get a huge dip in the response, depending on the size of the driver, 10K, 11K, 12K, 13K. It goes away off axis, but it's there on axis. And then with cabinets, especially if the tweeter is equidistant from the top of the cabinet and the sides, which they often just happen to be, you got maximum disturbance due to that symmetry on axis. So always listen slightly off axis. And so I design every one of my speakers for about the 15-degree off axis. It smooths out there. Generally, with most of the concentric drives I've done, the change in frequency response up to, say, 10 or 12K between 0 and 15 is not that much as a general trend. There's no more than a half to 1 dB change in level. So you don't get too much difference in the tonality of the speaker by changing off axis, but those perturbations go beyond that 1 dB, and so it's better at 15 degrees. So typically I go for either a flat 15-degree off-axis response or a slightly tilting 15-degree off-axis, and then that will mean it's either flat or slightly rising on axis. It depends on the size of, especially the concentric drivers, and then falling further at 30. And if you get the right kind of cone shape and tweeter in a concentric driver, you can arrange it that the drop from 0 to 15 to 30 is relatively small. Then once you go beyond 30, it starts dropping much more faster. So the polar pattern is a flattish front and then goes like that. So that's great for interfacing in a room. It means you got good tonality over most of the listening space, but then you're starting to you're dropping off more quickly for the off-axis response for sidewall reflections and room reverberation. So it's a nice directional characteristic if you can get it. So don't listen on axis. Listen about 15 off, but then which 15? Do you toe them to cross in front of you, or do you toe them to cross behind? And again, that depends on the characteristics of the speakers and the kind of soundstage that you like and how close your sidewalls are. So obviously, if your speakers are crammed very close to sidewalls, it helps to toe them in, especially if you've got a nicely controlled directivity pattern, because you can minimize that sidewall bounce without having to be so concerned about treating that sidewall. So you toe them in and you cross them in front of you. If you've got plenty of space to the sides, then you can choose toe them in front or behind. Towing them behind will give you a big image. The center image won't be as well defined, particularly if you're not exactly on the center line. Towing them in front will solidify that center image at the expense of slightly reducing the overall size of the image. Although interesting with concentric drivers, what you then do is you space them apart further than you normally would, and then tow them in aggressively to cross, noticeably in front of you. So that opens up the space of the image, but then re-solidifies the center image. And that can be a very interesting effect.
I have a random question for you, which we've been just asking all of our speakers this. What do you think about cable risers?
No comment. Makes it easier for vacuuming.
Yeah, good answer.
I've used through the years some very expensive cables of all sorts of constructions, and obviously you got people who fervently think it's bullshit, people who fervently believe in all the tweaks, and so I try and stay agnostic in my whether I support or don't support these concepts. I think some of the tweaks are stupid, especially when people try and explain physics behind it. And I go, no, that isn't physics. That physics doesn't work like that. And so I dismiss them out of hand. Now, as a scientist, using the true scientific method and the proper definition of a skeptic, these days, if someone calls you a skeptic, they're being insulting, saying you've got a closed mind. Actually, the original definition of a skeptic is an open mind that you're going to investigate and test. And all science, every theory that we have in the scientific method is based from observation driving it. You observe something, you try and find out why that happens. And you try and get a theory that matches every observation you can make and predict observations you haven't yet observed. And then you go look to see that new, try that new experiment that is predicting something you haven't yet noticed. And if it matches that, that further confirms the theory, and you go on and on like that. And the reason we've got better and better theories in physics and go, for example, quantum mechanics, is that we began to be able to observe things that we weren't able to see in the days of Newton when he had Newtonian physics. So observation is key to new discoveries. We can theorize, as we do in quantum mechanics and that realm of physics. We can theorize all sorts of crazy concepts, multidimensional space, but they're useless if they don't fit observations. They're just ideas. And so if I think like that, any crazy idea that someone comes up with, I should be open to and say, even though I can't tell you why it works, I can observe it does. But that also gets into the realm of, do I really observe it? Scientific method starts by you doing an experiment and getting some results and saying, I observed these results from this experiment. What you then do is get lots of people repeat that experiment. When you publish a paper on an experimental method and results, it's supposed to have sufficient detail that anybody can go and repeat that experiment and see the results. Or you've given enough data from your experiment that people can examine the data and come to the same conclusions from that data as you did. Sometimes they don't, often they don't. So you got this idea of testable observations and hypotheses. So sometimes we do get into a mindset of, that's so stupid, that doesn't work, you didn't hear it. And so now you're back into, well, did you hear it? Would other people hear the same thing? How do you reliably test whether someone can hear something? And then you'll get the arguments between people saying the only verifiable way of proving you heard something is double-blind tests. And then other people will say, yeah, but I've never been able to hear on a double blind test method, but I know I hear it when I'm at home. And so, well, of course you didn't hear it. Of course you didn't hear it in the double blind test because it doesn't exist. You just persuaded yourself at home it exists. And other people will go, no, but it's my mindset. It's the way I listen. I can't listen that way on a double blind test. So it's the double blind test that's at fault, right? So you got all this stuff. So I try and stay out of all these things. It doesn't mean I don't use them, because very often at a show, I'm partnering with other people, and you'll always get, if you've been successful enough at shows and get good sound at shows, people will throw things at you saying, oh, would you use my XYZ? And I once had, at CES, I got the chance to use crystal cable. And because of the system I was setting up, it ended up that I had $250,000 worth of cable for my demo. And of course, I didn't pay for that. I nearly paid. So TAD, part of Pioneer. So I'm at Pioneer. My Swedish dealers got this set up to arrange for me to use this cable. Well, they asked me if I'd put a safety deposit down for this cable. Can you give us €10,000? And this was just before CES. And so I went to one of the marketing people in Pioneer. I said, I need to write a check for €10,000. And he goes, for what? And I'm going, for some cable. He said, are you kidding me? Just for a deposit? Not to buy them, but a deposit to use these cables. And yeah, €10,000. So we need a contract for this. So I had to go to the legal department, get a contract, got all that done. Then they sent me the shipping invoice so I could track it and get it in. Well, they valued it at $250,000. I'm thinking, crap, that's 6% import duty on cable. I'm going to have to pay 6% of $250,000. So then I had to run to our import department and say, help, how do I not have to pay 6% of $250,000? And we managed to get that sorted out. So then I received $250,000 in a box of cables. I'm not shipping this to CS. I'm driving this personally in my car. And so, I got fantastic sound that year. But I changed so many other factors that no, I will never commit to saying if or how much percentage those cables contributed to it. Nonetheless, I got fantastic sound that year. But that's just, kind of this observational thing. I changed the room around, I'd got a new amplifier and all that kind of stuff. So, yeah, I'm not going
so you were helping advertise for crystal cables by putting them in your system, and they were requiring you to put a deposit down simply because they thought you might run off with them or somebody else might run off with them?
It was just a transactional thing. Who was I? It was a company that they'd never dealt with before. Oh. It was just a kind of a procedure that they have in their system. And, obviously I got it back. I'd never dealt with them before. I didn't personally know them. It was a recommendation through someone else. So that's all it was. And they apologized. They said, it's not that we don't personally mistrust you or anything. It's just, this is written into the company process. And so
good business.
Yeah. I was cool with that.
Okay, I think we only have about 3 minutes left. We do have a lot more questions, but we try to end things on time. I think we had a quick question about room treatments. If you're going to talk about tweaks and things, are there room treatments, spikes under speakers? How do you feel about those? Anything you like in particular? And with the brief amount of time we have left.
Well, obviously, the room is critical. So the first thing to commit to is optimum location of the speakers, right? Before you do anything else, try and move the speakers around to get them optimally placed. Both the position of the speakers and the position of where you're listening from. That will make, because especially at low frequencies, most people are never going to have adequate absorbers to treat the low frequency modes. You know, what we call bass traps for what most people buy at home don't do much at all. You need panel resonators tuned to the particular modes in the room, just like most studios will use. Most people at home will never have that. So your best bet is trying to optimize for the particular location. Because even EQ doesn't fix things properly for more than one listener, typically. So move them around. Position from the front/rear wall, side walls, spacing apart, toe in, move your listening space. Just endlessly move them around to do that. Then the right balance between soft furnishings, hard floors. You know, never just have a hard floor between you and the speaker. Try and put at least a rug there to catch some of that floor bounce. Maybe a bit of sidewall treatment, but you have to be careful with that because the simple treatments that you get are very unbalanced in their absorptive or diffractive characteristics versus frequency. So you can do as much harm as you can good by doing that, by unbalancing the spectrum of those reflections. Certainly, if you get too close to a back wall, you either want to be very close or reasonable far away. But if you're sitting about that far, a couple of feet, you can get a horrible early reflection from that back wall that really screws up the mid frequencies. So try and treat that a bit. The best thing is clutter. As much clutter in the room as you can get. Lots of things, bookshelves. We always say bookshelves and records. Spread those around.
Yeah.
Let's diffract and diffuse and clutter up those reflections. So that's a good thing. And drapes. My problem here is I have no drapes. Basically, every rule I just told you, I haven't followed at home. Which is why I understand the difficulty in doing all of this. I can't have drapes and, well, I can't have, with all these dogs, I can't have rugs. Put it that way. But those are the things you should try and do. Before you even get custom made acoustic devices, there's lots you can do with regular furniture and placement and say clutter to try and help. And spikes, if you've got suspended floor, spikes are a bad idea because there's a common misnomer that spikes decouple vibrations from surfaces. No, they don't. They maximally couple. They absolutely maximally excite the surface that they're coupled to. So if you're really wanting to isolate, you need suspension systems. And the problem with speakers is if you're trying to do that from too low a frequency, your speaker seems to be wobbling and people get nervous, especially in California, back wobbling speakers. It means a portend for what else is about to wobble.
Okay. Well, this is amazing. You have managed to get through most of our questions, and it's just after 3 o'clock. I salute you for doing such a good job.
Better than last time.
Yes, we did not have to. We have the Andrew Jones rule, which unfortunately we don't do that anymore. We never do musical interludes. We used to force ourselves to stop and listen to music, and unfortunately we don't. But I'm hoping we all listen to lots of wonderful music on ELAC speakers at home.
Yeah, that's right. And don't forget, go to Qobuz and look up the playlist.
And I think a lot of people have tried to do that.
Well, people have tried to do it through Rune. You have to go to Qobuz directly. You can't look it up through Rune. So just
Can't you?
Qobuz directly.
Okay.
Once you've found it, you can favorite it, and then you'll be able to find it through Rune.
Oh, is that the way you do it? Okay.
Yeah.
Okay.
Yeah. Yep. Yeah. So we're all going to be listening to your music tonight. And I thoroughly enjoy my ELAC speakers, which I have in my surround sound system, so, which have been great.
And they sound great.
Yeah, so they
Okay.
do, and we're looking forward to your next speakers and whatever adventure you choose to partake of next. And
All right.
hopefully one of these days we're going to see you in person.
Yes, so looking forward to that.
Thank you so much, Andrew.
Yeah,
All
thank
right.
you very much. This was really enjoyable, and yeah, stay safe, everybody, and we'll see you in a couple of weeks.
Yeah,
To
okay.
you.
Yes,
Bye,
thanks, Andrew.
guys.
Great program.
All right.
Bye.
Yep. Thank you.